All right, y'all. Today we are going to learn a new skill. We're going to learn how to graph polynomials from factored form. So please get your notes titled down, graphing polynomials from factored form, and get this example problem down. Graph f of x equals negative 3x times x minus 4 squared times x plus 3 to the fourth times x plus 4 to the fifth. And we're going to start by writing down our degree, our leading coefficient, and then sketching the end behavior. So let's go ahead and do those things. So really quick, when you have factored form, this is factored form, right? We see factors. When you have factored form, the degree, actually, let's go ahead and write over here, the degree, you're going to add the exponents. When you're in factored form, remember the degree was the highest exponent in standard form? Well, when you're in factored form, you're going to add the exponents. And here's the thing, y'all, a lot of students get tricked by one sneaky exponent. So really quick, let's just go ahead and note the exponents that we see. We see a 2, a 4, a 5, but there is a sneaky exponent. There is a sneaky exponent on this x right here. Right here, I want you to tell me, what do you think the exponent is on that x? Go. All right, the exponent on this x is a 1. So we're going to add the exponents. We're going to do 1 plus 2 plus 4 plus 5, and that's going to give us the degree. So we get 3, 7, 12. The degree is 12. So let's go ahead and write down 12. And what should we be worried about for degree? What should we be worried about for degree? Are we checking if the degree is even or odd? Or are we checking if the degree is positive or negative? Go. All right, we should be checking if the degree is even or odd. So let's go ahead and make a note. Is this degree even or odd? 12 is even. And then did even mean same? Did even mean your ends go in the same direction? Or did even mean your ends go in the opposite direction? Tell me, did even mean same direction or opposite? Go. Even means the same. So even means our ends are going to go in the same direction. Sweet. So now that we've gotten that, let's go ahead and kind of like stamp that by highlighting it. That tells us about the direction the ends are going. Now let's get our leading coefficient. So when you're in factored form, you see a bunch of factors or parentheses. The leading coefficient is going to be the number out in front, in the very front. The number multiplying out in front in factored form. So what number is sitting out in front? What is our leading coefficient? That would be this -3. The number out in front is -3, so our leading coefficient is -3. And then did we care, leading coefficient, what did we care about? Did we care about even or odd? Or did we care about positive or negative for the leading coefficient? What do we care about? Go. All right, for leading coefficient, we care about positive or negative. So this is negative. And then I want you to tell me, which side did the leading coefficient tell us about? Which side of the graph? Which end? Was it the right end or the left end? Which end did the leading coefficient tell us about? Go. Okay. The leading coefficient tells us about the right side, the right end. Right end goes down because it's negative. Because it's negative, the right end is going to go down. All right, so now that we have gotten the leading coefficient, we can go ahead and sketch the end behavior because we also have the degree. So let's go ahead and sketch that end behavior. Let's put that all together. And I'm going to draw a dot, dot, dot in the middle. We don't know what goes on in the middle, but that's what we're learning how to do today, which is pretty cool. We're going to learn how to graph the middle of the polynomial today. So first thing we can put on our graph is the right end. The right end is going down, so on the right side, I'm going to put an arrow going down. And then, because the degree is even, these ends have to go the same direction, so I'm going to draw the left end also going down. Sweet, so that's what our ends are going to look like. Now let's go ahead and define something new. Multiplicity. Multiplicity. So the multiplicity is, write this down, the number of times a root appears in our equation, or you could think of this as the exponent. This is the exponent on the root. The exponent on each factor. Okay, so let's go ahead and talk about why do we care about this word multiplicity? Why do we care about the exponent on each factor? Well, the exponent on each factor tells us if our function crosses or bounces off of the x-axis in the middle. So really quick, I want you to draw this example in your notebooks very quickly. And we're going to talk through this. So this orange dot right here is showing an example of bouncing off the x-axis. This is a bounce. And what a bounce means is you can't cross through. You're not allowed to go through the x-axis. You have to bounce off of it. See how my function, it hits the x-axis right here. It's traveling down, and it hits the x-axis and bounces off. So that's a bounce. And then a cross is when you're traveling down on this blue side, traveling down, boom, we cross through right there at x equals -3. So a cross, an example of a cross is drawn right here for you. And we cross through the x-axis in the middle. Okay, so let's talk about how the multiplicity helps us determine that. Let's go ahead and write this note. If the exponent on each factor, if the exponent is odd, actually I'll change my color. Odd means cross. If the exponent is odd, then you cross through. And as a reminder, odd numbers cannot be divided by 2. Odd numbers cannot be divided by 2. If the exponent is even, you bounce off of. You bounce off of the x-axis. Okay, so we now know why we care about the exponent, or the multiplicity of each root. So now let's write down the multiplicity of each root for the function that we are working with. So I'm going to write the function again right here. We're starting with this function, f of x equals -3x, x minus 4 squared, x plus 3 to the 4th, and x plus 4 to the 5th. All right, so we have how many factors? How many factors do we have? We're about to list out all the factors. How many factors do you see in this equation? Go. All right, I see 4 factors. I see the obvious ones are these things in parentheses, x minus 4, and then I see x plus 3, I see x plus 4, and then the last factor I see is 3x. It's actually the first factor, -3x. Okay, so let's go ahead and write down the factors in this box. So we have -3x, we have x minus 4, we have x plus 3, and x plus 4. And now let's write the roots. The roots is the same as, give me another word that is the same as root. What's another word that's the same as root? Go. The roots are the zeros, the x-intercepts, the solution. So let's start with this second factor, x minus 4. What does x equal for the second factor? What do you do to get the roots? you flip the sign. So x equals 4. For the third factor, x equals -3. For the fourth factor, x equals -4. All right, this first factor always gets people. -3x. My factor is -3x. How do we find the root? We set the factor equal to 0. So -3x equals 0. I want you to tell me, what does x equal? What is the root or the solution? What does x equal? Go. All right, we should use inverse operations. So to find the root, we're going to divide by -3, divide by -3, and we get x equals 0 divided by -3 is 0. So our root is x equals 0. Okay, anytime you have an x out in front, x in front, your root or your solution is going to be x equals 0, no matter what number is on the x in front. Okay, and now let's write the multiplicity. So the multiplicity, again, is going to be the exponent, and we need to state if it's even or odd. So what is the exponent? The exponent on our first factor, on the first x, well, that exponent is 1, right? So multiplicity is 1, and is that even or odd? Odd. So what's going to happen at x equals 0? So we're going to write at x equals 0, we're going to cross the x-axis, cross through. Sweet. Let's do the next one. What is the exponent on the x minus 4 factor? The x minus 4 factor has an exponent of 2. I'm looking at this exponent on the x minus 4 factor. I can do this in a different color, actually. Sorry, y'all. 1, 2. So 2, that's even. So at x equals 4, we're going to bounce off of the x-axis. All right, let's go to x equals -3, where that came from the x plus 3 factor. So what is my multiplicity? 4. 4 is even. Oops, trying to stick to the same colors, y'all. Sorry, 4 is even. So at x equals -3, we're going to bounce again, bounce off the x-axis. And I will show you how to like put all this together and draw it in a second. Okay, and then my last one is the exponent on the factor x plus 4. That is 5, which is another odd number because it cannot be divided by 2. So at x equals -4, we're going to cross through. Okay, and then let's go ahead. I'm going to change this. Okay, let's go ahead and now talk about finding the y-intercept. So anytime you're asked to find a y-intercept, you need to know this. Find a y-intercept, you're going to plug in something for x. Plug in x equals 0. That's how you find y-intercepts, always. So let's go ahead and find the y-intercept for our function. We have our function up top. We're going to plug 0, or actually let's use the version below, right below here. We're going to plug 0 in to f of x. So we're going to say, all right, f of 0 equals, and we get -3 times, I'm going to put parentheses around every time I plug in. Parentheses, we have 0 minus 4 squared. Parentheses, we have 0 plus 3 to the 4th. Parentheses, 0 plus 4 to the 5th. Okay, students often get freaked out when they see it in this form, but let's just take it one step at a time. First of all, what is -3? -3 times 0. Well, -3 times 0 is just 0. And then we have times 0 minus 4, that's -4 squared, times 0 plus 3, that's 3 to the 4th, times 0 plus 4, that's just 4 to the 5th. But really quick, y'all, look, there's a 0 out in front, multiplying. A 0 multiplying out in front, what's this whole thing going to equal? 0. So f of 0 When we plug in x equals 0, we get 0. So that means our y-intercept, what we were trying to find, y-intercept is a point. It's the point 0. We plugged in x equals 0, comma, and then we got 0 for our y. Okay, so we know we can put that point on our graph, and we will do so. Let's go ahead and graph this function now. Let's put all this together. Okay, we're going to start with our ends. Our ends, we know that both ends go down. Actually, we're going to start with our roots. So really quick, our roots are what x equals. So let's make sure we know what are each of the roots. X equals 0 for the x out in front, right? 4, -3, and -4. So your first step of graphing, graph the roots. And really the first step should be draw a grid or a graph. So let me go ahead and draw that. And we're going to go all the way to let's go all the way to 4. 1, 2, 3, 4. And -4, -4, -3. This is x equals 0, 1, 2, 3, 4. How did I know to go to 4? Well, because my biggest x is 4, my smallest x is -4, right? Okay, and then we don't need to necessarily go anywhere on the y-axis. We just need to make sure we have our y-intercept on our graph. All right, and we're going to graph our roots. So let's get our roots on the graph. X equals 0 is my first root. Well, the roots are the x-intercepts, right? They have to touch the x-axis. So the x-intercepts touch the x-axis. 0 is right there. X equals 4 is right here. X equals -3 is right here. And then x equals -4 right here. Cool. Second step. Graph your ends. End behavior. And then we're going to do the right side first, usually. But we already sketched our end behavior up top, remember? And we know that both ends are going down. So the right side is going down, and then the left side had to go the same. We found that up top. All right, and then our third step is to say, are we going to cross? Third, cross through, or bounce? Okay, so we know we have to touch these roots. We have to touch all of the pink points, the roots, the zeros, the x-intercepts. But we don't know if we cross or bounce at each one. So remember, if you're odd exponent, you cross, and even exponent, you bounce. We found those earlier. At the first, actually, let's start left to right, y'all. Let's always look left to right, like the same order we read. So let's look for the factor with x equaling -4. Remember, you flip the sign, so that's this factor. So this comes from an odd exponent, so we're going to cross. We are going to cross at -4, cross through. And then at -3, that comes from an even exponent, right? An even exponent. So we are going to bounce. So we're going to come down, our polynomial is coming down, and it's going to bounce off the x-axis. 0 at x equals 0, we have the 0 came from an odd exponent, so we're going to cross through. So we are going to now change to blue, and we're going to come back down and cross through 0. And then the last solution we have, or root we have, is x equals 4. That came from an even exponent, which means we need to bounce. So we're going to bounce at x equals 4. All right, sweet. And then we are done. Odd means cross, even means bounce. Do you see how we bounced? Bounce here, and it's because of the exponent that was on the factor that the root came from. Okay, cool. Let's get some practice in.